Hello everyone, I'm Xiao Gang. Okay, let's continue writing this calculation. This calculation is quite important, so we need to break it down into many steps. First of all, we need to do it this way. Let's first prepare an enum like this. Prepare an enum like this. Okay, note that for this enum, we need to make sure the names are consistent. Because if you don't meet certain conditions, we don't need to send it out, and we consider it invalid. So let's first prepare such an enum. We haven't given it a numeric value. Right, let's ignore it for now. First, let's get the information from our remote server. This server may need to be accessed multiple times. So we need to prepare an interface to declare it. Let's write a protective interface, because we might need to get it and call it multiple times. Because it might change, possibly during debugging. It might change again. It keeps changing back and forth, so we must refresh it. Then let's prepare the variables here. Because I don't want to write a return word for this parameter. This way, every time I write it, I still have to load it. That would be quite troublesome for me. So here we'll just prepare two variables directly. Then here we'll draw the numbers. Okay, good. After drawing the numbers, we use this function to refresh its current value. We directly use, it uses this method. This method, we directly get its default CDO object. Then we load it in. Obviously, we need to include the header file here. Okay. After we include the header file, it should be able to recognize it. Once it is recognized, we need to perform a validation here. It is possible that this field is empty. You didn't write anything. You didn't fill it in. And if this port is not a number, then obviously there is a problem. So we will log a message here. We consider that you have made an error here. Then we need to include the log. We will copy this log over. Okay, so obviously this thing here of yours, it has a problem. If it succeeds, then it proves the verification passed. We are just doing these for testing. We'll hit the server port. You can delete it later or block it if it doesn't exist. We'll return false. It proves that this place actually has a problem. So if this place has a problem, it's not for me. This is for us to see. This is just for everyone to see. And this return false is mainly processed above. This place is here. Process it here because we hope that through each round, we can control it because the people using this plugin are many. They are not necessarily the developer. They could be designers using Blueprint or some other team member. Since this is a plugin, after you execute it here, it means a local loading of information failed. So we take the current information and parse it, fail to resolve the server IP and port from this. Then we will just execute this proxy directly here. We let it for a loop and return this array. So when you receive this array, you will know, oh, it failed. The reason for the failure is that resolving the IP and server port failed. Then next, we need to make a request. We need to record this proxy. So how do we record it? First, we generate this proxy. Give it a GUI ID. After the GUI ID, we add this check ovation to an array. Then we store it. So how do we store this? It's actually a bit complicated. What I designed here can serve as an advanced learning opportunity for everyone, which is also quite good. We'll put this down below. Okay, no need to put data below. So we have prepared the type of decoration, and it is in the form of GUID and stream and the GUID. Then you add it here. Whether to add it here or not, the unique number should definitely be unique because GIDs cannot be duplicated. Then next, let's collect the current version information because we are now releasing this confirmation version. So let's prepare this data. We don't have this request data yet. So first let me take a look. Then we will need a struct. Because we want to do it via JSON, so we need to write this struct here. We need to learn about this struct here. So we will call this struct calculation data. We haven't written it yet. So let's write the struct here. Wait, the code here needs to be consistent with the server. And when writing this delegate, we also need to write a lot of this stuff. This stuff is quite complex. Let me think about it. Let's not write it for now, because writing it here would be too complicated. After we get the framework running, we'll write this communication framework for everyone. Because after writing the communication framework, everyone will understand how commercial code is iterated. Assume we've already written the request data here. Right. Then we send out this verification version request. Actually, this hasn't been written yet. Let's give it something simpler. Let's just call it 2, 3, 4. And this locking data, actually we don't have it yet either. But this thing should be writable now. Let's write it out. It's in the request data, in the request type. First, we need to define an enum. This enum is for, what is it used for? It's used to distinguish which interfaces we have. So obviously, we need to include this, include its header file. We need to include this type. These are some base class in. Okay, then let me take a look at the header file. Here, we need to change the name. Okay. Then after entering our name, we won't change the other names. That's it. So actually this request is check wasn't request. We don't need these other requests. We'll delete them to keep it clean. Okay. This enum is mainly for indicating what kind of request we are making. It is placed in this position. Then here we send this request. And this is our request data. This is our request ID. Okay, so when sending this request, let's start writing this request method. Because I want all our requests to be sent through this function. So here we write a raw HTTP, and this thing actually we also need to add a public. We put the public here a bit higher. Okay. So it actually defines which enum, what information was sent, or what key. Let's paste it here. This is when we actually instantiate our HTTP. Instantiating HTTP is the same as our previous process. We need to get our FHttpModule here. Then we need to set up this binding. This binding method. We have made a constant here. Yes, we haven't taken a look yet. We will set up a binding parameter here. Let's do it this way for now. Yes, we need this binding method with payload. Like this. This is for receiving. We receive compared to the original request and response. We also have big 6. It is the native function signature. These two are the ones we added. We want to know what type it is, so we can dispatch it properly. And the request type here is actually passed. This should be it. Okay. Good. Then there's no problem. Then let's create its implementation. Then back to our previous flow. Actually, this is 1, this is 3, this is 1, this is 3. After we bind GTDP like this, we need to assemble our URL. This URL is actually what we read. Ligand server IP and SOAP and server port. We read it here at this place. Actually, it's still together. That is, still on a single thread, executed within one function. It first reads the record itself, then collects version information, send it from this place. When sending, we concatenate this URL. Then we set this URL, then we uniformly use post and the format of our information. When we use it, application, and it has many formats. You can open our Postman. You can see it actually has many formats. We all use Tiesho here, then we will demonstrate later. how to use upload or some other formats. You can see like this body. You can see it actually has many such formats. Let's change it to post. Right. Okay. Then let's continue looking below. Now we are sending. Suppose we send a JSON over. As for whether it is actually JSON-V, that depends on our agreement with the server side. Then we set this data in. Then we send it out. Let's take a look at this request body. It should be. We'll just write this data like this for now, because this will become very complicated later. This way, the server can receive it. Similarly, on the client side, after we send the data like this, we first give the client a login server result. What is this? This is just a return result. It is written here. Actually, all of these correspond to each other. You can see, if you are observant, you can see. Let's paste this. Okay. Here we need to make a change. Okay. Then we won't change the name here. These can be replaced later. Let's go back to our subsist. Here, let's first assume it's a network error, right? Check if it contains it. It should contain it. We need to compile this because we've written a lot of code. Okay, there's a compilation error. It says it can't open this YouTube tool. Let's check this example server youtube.h and see if the text is misspelled. Obviously, the name here is wrong. We just need to change the name because we haven't written the code yet. This is very convenient to put away. Actually here, the name here is written incorrectly. Then at this point, we compile again. Okay, compilation still fails. We check this compilation error. Obviously, it's this place. This file hasn't been modified. Let's compile again. Okay, still reporting errors. Let's check again. With this kind of error, we find it says the reflection file for this. The reflection file for HTTP type has an issue. Check it. Here we press enter. Then we might need to delete some. Execute again. So this is the place, because the issue here is quite troublesome. Let me pause for a moment. This problem is caused by this place right here. You can see it is the request type. But what we included is another JRT. This means we got it wrong. This method was written incorrectly. That's why this problem occurred. We need to continue checking. Look, this place shows an undefined identifier. Now, the error here is different again. Let's take a look. Unmutated identifier. We can paste it over. Then we actually defined it here. The reason it wasn't found here is because you can see we can identify it by dropping the pig. But that thing, once released, it's gone. That's actually because when we did step 3 earlier, you added one too many of 3. Go ahead, there's one extra 3 here. Let's add it back. Here it is actually. Actually, it should be this. It should be this. Look, the name here is wrong. Yes, the name is wrong. Because it points to this return all types. Let's compile it again. Okay. Then here we have an extra line. Let's delete it. Good. Now let's continue to improve this. This part is a bit tricky. Good. Here we still use the same judgment method. Let's just write it simply for now, because this still needs further improvement, okay? This part is quite complex to write. So here, as long as it succeeds, we need to print a log, record whether it succeeded. For this log, we need to change this log. For this log, we copy it over like this. For this log, we first get the data it returns. We'll just print this data directly. We won't do anything else for now. Okay. We'll just put this thing here. If it succeeds, we execute this. After it finishes executing, we still need to go through this proxy handle. We need to find this proxy handle, then execute this blueprint callback. So we won't execute the blueprint callback for now. We actually have some failure judgments here. We don't have that here either. That is, if we succeed, we use this GUEID to find the delegate. Find this delegate from here. Then pass the execution result from our side to it. Okay, let's stop here for this lesson. Okay, this place is our number 1. Then later, through the net, jump to our server. Then after the server returns, 1 month is our number 3. And this place, this enum mainly defines the server's return results. The server may succeed, may fail. It could be something else. Your reason caused it to fail. Then this is the result returned by the server. As for this enum, it mainly defines. Just like when we make a request, we will pass this enum along so it knows what type of request it is. We also know what type of request we are making this time. And this response is mainly what is returned. You see RSSP, then you returned. You initiated such a request. Then you must necessarily return such a request enum. Only then can a simple correspondence be achieved. Okay, in the next class, we will conduct a simple integration test for everyone. Okay, that concludes this lesson. Thank you, everyone.